Welcome to my channel, and here we are going to solve this problem as we are instructed here that the elevation of a truncated cylinder is shown below. Question Roman figure 1 says we should draw full size the given view, and Roman figure 2 says we should produce the pattern development of this particular object. And if you look at it, is a truncated cylinder. And then let's talk about the dimensions of these view that we are looking at. So we have the distance from here to this point is 65 millimeters, and distance from here to here is 50 millimeters. And then we have that this line is at angle 45 degrees to this vertical center line, and then we have the diameter of the cylinder to be 50 millimeters, while the radius of this arc is 25 millimeters. So what we are going to do, as we are instructed in the question, is to reproduce the given view. Then we go on to produce the pattern development of this truncated cylinder. Now let's go and do it as we are instructed. So the first thing that we need to do is to draw the vertical center line. So I'm going to draw a vertical center line here. Then I will go on and produce the horizontal center line. So it goes like this. Then we go on to construct the circular base of the cylinder. So we 25 millimeters is the diameter, is the radius. So the diameter is 50 millimeters. The radius is 25 millimeters. So take a measurement of 25 millimeters. So we put at this point, and then we draw a circle. So we draw a circle. Okay. So this circle we are going to divide into 12 equal parts. We divide the circle into 12 equal parts. So I'm going to use my set square to do the division into 12 equal parts of the circle. So I have my set square here, and with my T-square. So I'm dividing this circle into 12 equal parts like this. Then, so we turn to this side. Alright, so we are dividing the circle into 12 equal parts. We are going to number the points on the circle. So I will call this point, this is point 0. So this is 1, this is 2, this is 3, this is point 4, this is 5, this is 6, this is 7, here is 8. So this is 9, this is 10, this is 11. Alright, so with what we have done now, the next that we are going to do is to produce the given front elevation of the truncated cylinder. So we come up a little bit and we draw horizontal line. So we draw horizontal line like this. Then with our set square, we are going to produce a vertical line. So from this point 0, we draw a vertical line. So it goes up. So it goes up like this. And then, so at this point, so this is point 1 and 11. So we draw a vertical line to meet the horizontal line. For point 2 and 10, so we draw a vertical line to meet the horizontal line. So we have done that of 3 and 9. So for 4 and 8, we draw a vertical line to meet the horizontal line. And then, so we also have this 5 and 7. So we draw a vertical line to meet the horizontal line. And here we also draw this for 6, and it goes up. Also for these ones also, I can also do the same thing. So I can also produce direct vertical line for each of these. So let me do it at once. Okay, so we also draw a vertical line at this point. So here we also draw a vertical line at this point. Alright, so now, so we need to take the given dimensions. So we are told that the height is 65 millimeters. So we take a measurement of 65 millimeters. Okay, so this is 65 millimeters here. Okay, so having taken 65 millimeters, so we are going to draw a horizontal line We are going to draw horizontal line here. So here we draw horizontal line like this. So the next thing that we are going to do is that, as we have in the diagram, so we have the distance from this point to this point is 50 millimeters. So I need to take a measurement of 50 millimeters here on this side, 50 millimeters here. This is 50 millimeters. Okay, so I've done that. Then another thing that I need to do is to take my 45 degrees set square and put it at the center here. And put at the center here. So I put it at the center. So putting it at the center here, so I will draw this line and make it a thick line. So we have this. So then we can connect these 2 points together. Okay. Then I can make this line, I can make it a thick line. So we need to make it more visible. So I need to make it a thick line. So the next thing that I'm going to do is that I'm going to take my compass. Then I will put it at this point. For us to draw the arc, I'll put at this point. So putting at this point here, so it touches the center line. Then I'm going to draw the arc like this. Alright, so the given view has come out as we are instructed. So what we need to do now is to make this line a thick line. So make this line a thick line, and then we also make this line a thick line. Alright, so we have drawn the given view, we have drawn the plan, though we are not asked to draw the plan, but we cannot draw the front elevation without constructing the plan. So please take note of that. Next thing that we are going to do is to produce the pattern development, or we call it surface development. And though we are not told we are not given the seam, that is where we have to cut the cylinder from and spread it. But I'm going to take this point as the seam. So I'm going to call this point, I will call it point X, point XX. So this is where we have the seam. Now let's go and produce the pattern development of this cylinder, truncated cylinder. So what we need to do now is to draw a horizontal line from here. And also, so we come to this point, we also draw horizontal line like this. And then, so come down a little bit, and then we move away from the given view. So we draw a vertical line here. So here we draw a vertical line. Okay, then we are opening from here. So this is 0. So this is where we have 0 here. So this is 0. So I'm going to number this point. I'm going to number it 0. Then I'm going to calculate the circumference of the circular base of this cylinder. So that means we have 50 times 3.142. That is the product of the diameter and the value of pi. So we have 3.142 times 50. So that gives us 157 millimeters. So what I'm going to do now is to take a measurement of 157 millimeters from this point 0. 157 millimeters from this point 0. So this is 157 millimeters. So this 157 millimeters, I'm going to divide it into 12 equal parts. So I'm going to call this point, I will call it 8.0, because when we cut from here, we are going to have 0 on both sides. So for me to divide this distance 0, 0 into 12 equal parts, I'm going to pause the video and do that, because I believe you should be able to divide a given line to a number of equal parts. And welcome back. I have divided this distance 0, 0 into 12 equal parts, as you can see here, and I've also erected vertical line on each of the points that we have on this line 0, 0. So what I want to do now is to number accordingly. So if you look at it, we start with 0. So the next number that we have after 0 is 1. Then 11 goes with 1. So I'm going to put 1 here, and then I put 11 here. So next is 2 goes with 10. So I have 2 here. Okay, then I have 10 here. So next is 3 goes with 9. So we have 3 here. And here we have what? We have 9. So next we have 4. then it goes with 8. Okay, then we have 5, so 5 goes with 7. Sorry, this is 7. Then we have 6 here in the middle. So let's take note of that. Now the next thing that we are going to do is to draw the surface development. As I said, we have started it already, so we just need to transfer what we have here so down to this place. So that's what we need to do now. So we are going to make use of our compass to do that. So I'm taking my compass, and I also need to take my pen to put inside the compass. That is what I'm doing now. So we now begin to take the distances. So let's start. So we start with 0 here. So we are going to start with this part that we have here. So here we have 0. So we take distance from here to here like this. Okay, so I need to take this pen up a little bit. Okay, so we take distance from here to this point. Okay, so we put it on 0. This is 0, so we put it on 0, and we make an arc here on 0, and then we also come to this point 0, we make an arc here. So we have done that. So next is we also have distance, so from here to here. Okay, so that is for 111. So we take this distance for 111, so we put it at 1, so we make an arc here, and then we put it at 11, so we also make an arc here like this. So next is we have 210, so we put it at this point. So for 210, so we extend it to this point, and we put it at 2, so we make an arc at this point here, and here we make an arc at 10. We put it at 10, so we make an arc here on line 10. Alright, so we have that. So everything will be connected to 3 at this point. It will be connected to 3 here, and this will be connected to 9. So we have taken that. So the next that we are one that we are going to take is this upper part. So on 0, so for 0, so we have it from here to here. So we take this distance, put it on 0, and we make an arc here. Okay, then we put on 0 here, so we also make an arc here on 0. Then the next is we have 111, that is from here to this point here. So we put it at this point, that is for 1, so we make an arc here. So we put it at this point for 11, so we make an arc here. That next is 210, so 210, so we take it up here. Okay, so we put it at 2, then we make an arc here. We also put it at 10, so we make an arc here. So everything will be connected to 3 and 9. So this will be connected to 3. Okay, so while this is connected to 9, so we have this point. Next, so we also have this part being cut off. This part being cut off like this, and we have this to be on 4 8, then 5 7, then 6. So from this point for 4 8, so I take this distance from here to here and put it on 4. So I put on 4 here, so I make an arc here. Then I take it to 8, I make an arc here. Okay, so next we have that of 5 7. So I take the distance from here to here for 5 7. Here I put it on 5, I make an arc here. Here I put it on 7, and I make an arc here. So last one is from here to this point on 6. So from here to this point on 6, I put on 6 here, and then I make an arc here. Alright, so all these points, we are going to join them together with the use of a French curve. So I'm going to do that, but I need to bring out the points so that we can be able to see them. Okay. Okay, so alright, so I already have the point. I was looking for the point. Okay, so we have this. Alright, so now we take a French curve to join them together. So here we have So this point being joined, okay. Alright, so I have that. So the next is on this side. Okay, so we have this joined together like this. So the next is, so this part that we have here. So let me see if I can join the 4 points together. So let me join these 3 together. Okay, so join these 3 points together. Then, so we join these 2 points together like this. So then we come to this side here. So I will join these 3 points together like this. Okay, so then we join these 2 points together. Alright, so and then, so here we are going to connect, so these 4 points together like this. Alright, so then I will connect these 4 points together like this. Alright, so we have that. So the last part is that we need to make this a thick line. So make this a thick line, and then so this part also we make it a thick line, and then okay, so that's all. So this is the pattern development as we are instructed, or we call it surface development. As simple as I've done it here. All you need to do is to practice. When you practice it, you become a master at it. Thank you, and God bless you.